Okay, so we're starting. Welcome everybody to our second TWed of the fall 2020 semester. Just a little bit of logistics. These are being recorded and posted via the Tetherless World YouTube channel, as well as based on general interest, also the IDEA website, idea.rpi.edu. Jamie, I'm assuming that you'd like to kind of talk, and if people have questions, do you want people to interrupt you, or do you want them to Slack it and we'll interrupt as appropriate?
Interruptions are fine. This is mostly going to be an informal and live demo.
Okay, that's great. So without further ado, welcome to Jamie McCusker, who's going to give us this kind of a knowledge graph and Whyis exploration tutorial and demo. Take it away.
Okay, so Whyis, for those of you who are not familiar, is a knowledge graph development platform. We've been using it for a number of projects, and we've been heavily working on basically on the visualization side of knowledge graphs for the Nanomine and Materials Mine project, which is a collaboration with a number of other universities, including Duke, Northwestern, University of Vermont, and Caltech. And we've been working to kind of put together essentially different ways to visualize a material science knowledge graph based on curation of data from a number of papers. And actually, this is a little old. It's actually over 2,000 experimental samples in the Nanomine graph. Yeah, so a lot of this data is fairly, let me see if I have, that's not it. A lot of this data is actually fairly complex. There's a lot of material properties. Those properties can have basically like uncertainty ranges. They can have independent variables that they are based on. And a lot of these things result in a really wide diversity of representation. So what we've been able to do actually is to kind of simplify that down so that it can be used in a more consistent way. And actually, I'm going to mine. There we go. So I'm actually going to show some figures from our paper and not show my illustration. So we're basing within Nanomine. We actually use the SIO ontology, the Semantic Science Integrated Ontology, which allows us to basically, it's an upper level science ontology that talks about object processes, measurement values, roles, and so forth, along with representations for space, time, and information. And we're actually able to apply knowledge curation to actually, we built out a ontology based on the data that was already being represented. We can represent uncertainty and independent variables. SIO does very well with attributes, including units and so forth. We're able to represent material composition, both the kind of in the case of polymer nanocomposites, actually made up of what's called a matrix, which is like a like if you were to take let's say you had pudding and you put raisins in it. So the pudding would be the matrix. It's kind of a amorphous thing, and then the raisins would be the filler. They're kind of things that you add into it. And obviously, depending on how many raisins you add, the property of that pudding would change drastically. You can have something very dry and kind of clumpy and lumpy. If you have a lot of raisins, you can have something very thin if you have just a few raisins. With nanocomposites, it's similar, except the properties that are being measured change even more drastically with just small changes in the amount of raisins. And also, we can have obviously, we can treat the filler with coatings of various kinds. So we can sugarcoat the raisins before we put them in, or we can put a yogurt shell on them, and that also changes the properties. And that analogy I literally just made up. We can also talk about how the processing of those materials, how it comes together in the graph. And actually, one thing we do is we take advantage of the provenance capabilities of Whyis in order to talk about how, not just how the material was processed, but also what paper it came from, who published it, and so forth and so on. So the result is this nanomine knowledge graph. And actually, one thing before I kind of get into this, I'm going to show the so nanomine.org, go to nanomine.org, and then actually click on visualization, and that'll go to the official one. But one thing that I do want to show is, in addition to kind of free-form visualizations, we actually now have the ability to essentially display canned visualizations, and this is where I'm hoping things are going to work. Please work. There we go. Okay. So we're actually able to take a visualization. In this case, we're trying to see, as you remember from the diagrams that I showed very, very quickly, we're actually able to see kind of how those different methods are being used together. And as you can see, most things are mixed and then mixed again. And then things like curing are very rarely used. But you can actually also see kind of how these things are used together. So this gallery essentially lets us kind of see very quickly the different kinds of visualizations that we can have. One cool thing about the gallery itself is that it's now it's actually available for all kinds of things in the graph. So not just charts. So if you have samples, you can actually look at the gallery of samples, people, organizations, papers. Basically, for those of you who are familiar with the standards, basically the graphic back there is from Fof depiction. This is actually from the label, DC terms title, or similar labely property. And then this is the description, which comes from, again, description-y properties like Fof description, or DC terms description, or abstract, or RDFS comment, so forth and so on. So let's see here. Now, one thing, and so some of these visualizations like this actually are useful across a number of different knowledge graphs. This is actually a view of the different publishers that are that we have papers from over time, and obviously, and so since we conform to the metadata that DOI.org publishes, basically we can, if we ingested a bunch of metadata from dx.doi.org, we can reuse this visualization for that. Actually, it doesn't look like I can edit this one. I can actually see, for instance, you can see the query that's being used for this, and that it actually is based on Dublin Court terms, and is yeah, lets you do that. And so one thing I'm going to show you is when you edit a chart, what kind of goes into that. So there's basically a few pieces to it. So there's the query, a SPARQL query, which is just literally any SPARQL query. There's a Vega specification, which in some ways is actually fairly straightforward. As you can see, this is actually a very simple specification that we were able to use. And then there's actually some metadata that we
Jamie, could I interrupt for just a second?
Sure.
So what's really interesting to me and what's logical to me actually is you're using select queries to pull in the data, and it makes total sense for the kinds of data that you're plotting.
Mm-hmm.
I'd contrast that with, say, the kind of rendering that the TWed portal does, for example,
Mm-hmm.
where you are displaying sort of a bunch of instance data, filtered instance data for a particular object, or like a person or whatever.
Yeah.
So most of the queries that you have that populate the pages in the TWed portal are described queries, where you're getting the stuff back. And it's not like an either or thing. That has a particular task. This has a particular task. These kind of queries that you're showing are actually what I used a lot on in the early Deep Carbon Observatory portal, because I was sort of constructing these pages based on these complex select queries coming back and kind of doing it like so. It makes a lot of sense. Not to get ahead of you, but where does I guess it's Vega where you're doing any theming and styling and stuff, right?
Yeah, exactly.
Okay, I'll shut up for now.
Okay. Although we're not actually doing a ton of styling in these. There's one that show you that that's the case. But essentially, when you're so essentially you get so this is actually using a few key technologies here. So you probably recognize Yaz GUI, and then the Yaz GUI results table, and then, like I said, Vega actually is that spec view. Now, theming actually is usually part of the Vega spec, and so you would essentially configure these fields or the encodings depending on how you want to show it. And in fact, we do this here. We actually provide a sort because we're having some Vega was doing something interesting with the sorting that we wanted to.
So you're forcing it.
Yeah, exactly. And in fact, so here we actually order it descending, and then because we could order it by Y descending, except that then it would actually not be quite the same order. So we wanted to make sure that these actually ended up in the same order. So and actually it doesn't work anymore.
So is the customization of these a lot like CSS? Does it work in the same way? Like if I wanted to customize how field is or title is, what I do
Yeah.
that similar to how CSS works.
So Vega-Lite is actually is very well documented in terms of what it is, what it can do.
Don't let me get you off the track from where you're going.
No. So yeah, so actually I don't want to go too much into the specifics of Vega-Lite because that's like a whole thing in and of itself. And actually, we're looking at in the future, we're actually looking at implementing Data Voyager as a alternate editor to this, so that when you have a new when you have something that you're basically, if you have a SPARQL query, you can uh, rather than knowing exactly how you want to encode this or knowing the Vega encoding thing, you can actually build that visualization from the table. And it's an interactive tool rather than kind of a text box.
What if you can't do all the transformation that you need in your SPARQL?
There's some transformation you can do in Vega as well.
Okay.
I'm trying to think if if we have examples of that I can show.
I mean, if it was SQL, if it was SQL, I mean, you got a lot of stuff you could do, but SPARQL is kind of limited.
Right. Right. And I'm trying.
Yeah, I'm just kind of wondering if there's like a in between that you can, where you go from the results of your SPARQL to your do some kind of additional data pipelining and then into your Vega, or as you seem to be implying that there's like something you could do in your Vega, which is going to be that pipelining.
In fact, we do that in this one. So there's you can have this transform block that lets you basically calculate new fields based on different things. Actually, as you can see here, it actually tries to collapse some things that aren't quite
right. So you can do like mutates if you want to do and all that kind of stuff. Okay.
And so you can actually see here in this example, kind of access formatting and setting up tooltips to be a particular way.
Okay.
And then actually, so in this here, it's actually kind of hard coded the values, which is kind of nice in some ways because this tool doesn't know anything about SPARQL,
right?
And so it needs a little bit of help there. So one interesting thing that we're working on right now is actually we also have a faceted browser that lets us look at basically different properties of the the thing that's being looked at. So in this case, we're looking at polymer nanocomposites, but this is actually set up so that it's not just one kind of thing that this facet browser works with. You can basically configure these facets to work on any RDF type in the graph. And so if you go to something that has basically any OWL class in the graph, you can actually pull up a faceted browser for that type. And at least in the cases where you have properties about those things and things are decently populated, it will actually introspect that graph and attempt to build out these facets for you based on the properties available. Now, obviously, since it's doing kind of heuristic introspection of the graph, it's not going to be perfect. So often you want to do that. You want to configure these manually when you really want to do something important. But it's actually it does an okay job in a lot of cases, and we're working on trying to make it better. But one thing that we've done is that because this is actually a this is a SPARQL query, right? It's running a SPARQL query behind the scenes, and right now what it did was it asked the server for kind of the constraints that these built out into, and then that the server then responded back with not with the query results, but actually with a query. And then the faceted browser now has a SPARQL query it can use to look up data in the graph. And so right now that's what it's doing is it's actually searching for basically this table. So it's basically has two numeric properties, and then it's actually going to pull back the different kinds of raisins in the graph. Red versus golden versus currants versus cranberries, and then the different kinds of puddings. And in the end, you get a table, which right now is just a nicely formatted table with the URI and then each value. And then later on, we're going to change this so that you can actually download it. But the other thing you get is actually a Vega chart editor. So we can actually look at these different values and plot them out on demand, and look at, for instance, how so for those not familiar with glass transition temperature, that's actually the temperature at which a material goes from being rubbery and pliable to kind of glassy and brittle. And this is in Celsius. Celsius. And so essentially we're looking at, for instance, and so we don't have the tooltips exactly right here yet, because it's showing the actual column names, the variable names from the query rather than the actual the labels. But what we actually have are the values plotted out. Now, one thing we can do is we can actually filter based on range, so that you can only speak. Hello there.
How do so many data points seem to land on the same mass fractions?
I think that's a precision thing. So these are log scale.
Mm-hmm.
So point, and remember these are reported in papers.
Right.
And so what's going on is that this is actually often an independent variable. They'll vary the mass fraction and see how that glass transition temperature changes as things kind of get less or get more sparse. And so and I think they generally will pick the same numbers over and over again. So 0.01, 0.02, 0.03, 0.05. This is probably 0.04. And since this is on a log scale, kind of towards the bottom, it will get choppier because we're looking at 0.001, 0.05. So it kind of there's no point in doing 0.0098.
So
and so it kind of rounds out.
So now, can this being a knowledge graph, take one of those data points? Can I find the source? Find I want to find the source paper or the table that came from, or the paper
Right.
that came from.
So we can actually do that.
Well, that's what that's why I'm asking, because what you're doing here is it's it's very similar to what the Deep Carbon Observatory people aspire to by gathering all of that materials data.
Right.
Part of it was harvesting from all of these historic papers.
Yep. And so we have in here we actually have the different nano publications that are available. We have the we can actually look at how various pieces are used. Actually, what I'm trying to find here is often a this one doesn't. Does this have control? Let's see. Does not have a control. Right, so some of these have control samples, others do not. I think these are actually all different. Oh wait, here it is. So this is right. So this is actually the control version of it. We can look at that. The other thing is that look at the actual nano publication that it was published from, and it does not. We're not yet able to look at the others. Those are taking a little while to render. Yep, there we go. So this is the entire knowledge graph. When the provenance, when that renders, will. So one thing it was doing is actually looking up labels for everything. Labels for stuff. There we go. So the provenance graph should have the publication information in here. And so here it is. So here's the article, and you can actually look up the. We can look up that article. It will take us out to the DOI once there's time. Actually, I think what it's doing right now is loading. There we go. We don't have we're still working on the actual article view for this. But this is a actual DOI that will go to an actual paper. And so we actually have all the provenance stuff too. Obviously, I had to do some kind of jumping around to get to that. We haven't quite gotten the visual links in place there yet, but that is on the list to improve. So one thing that I wanted to note was that if you remember, I said that this is actually generated from a SPARQL query. The next step for this process is actually to provide the ability to, and this does nothing yet, but at this point this is also done using Vega-Lite. The SPARQL query is a SPARQL query that populates this Vega-Lite spec. And so essentially it's doing the same thing that we do with the saved charts. So at this point, all you would need to do in the very near future is to kind of turn this into a canned a canned visualization is to provide a name and description, and it will save it into the graph as a visualization and add it to that chart gallery so that other people can see it.
What information would it store with it?
So so it's storing it as a nano publication, and that nano publication. Let's see if we've got these. Um, right. So hope this works. Yes. So we have essentially the fact that it's a SIO chart, and that's actually how we know what to do with it. It has a description, has a title. I'm going to make this bigger for the folks in the back. So it has a description, a title, a SPARQL query, and a value, and then also a depiction. So the depiction is actually just, oops, that's not the right thing.
Well, that's like a version of the depiction, right? If any of that data, if any of the,
So it's basically used as a thumbnail. So
right,
yeah, so
yeah.
so it does not re-render the view. Oh, why was that working? We've had some challenges with downloading files sometimes. Anyway, this is yes. So this is the actual. This is a URL to basically we store the actual a PNG thumbnail of uh, the visualization in when we save the chart. So it's actually the thumbnail of the last what the user sees right before they save it.
Yeah, and that's needed to have an efficient thumbnail.
Right, exactly. The other thing is that there are
So I'm sorry to drill into this, but this kind of interests me. This goes back to my digital repository days a million years ago. That there's this idea of I have the URI for the object, and I it could be it could point to a rendered binary, or it could point to the code that generates a binary, and it really doesn't matter. I mean, if nothing changes, then like caching the PNG would be fine, right?
right. In this case, the thumbnail is actually a different URI. It's a different entity from the visualization itself.
Mm-hmm. So you would pull on one thing if you wanted the actual visualization, and the other is okay. That's cool.
Yeah. So yes, actually, and but in the future, I'm imagining having a view that just renders the chart by itself, so it can be embedded in other things. The other thing that I really would like to be able to do is obviously these are great standalone resources, but once we have a lot of these and the ability to kind of have some decent layout CSS, which so we've had a very talented web developer, Talumo, working with us on the materials mine project. He's been making some great improvements to Whyis in the process, and a lot of these newer user interfaces he's kind of put together. But as we kind of improve this stuff, one thing I think would be really neat is to be able to kind of compose multiple visualizations and content from different entities together into a sort of into a kind of poster. And it could be that,
or a notebook or whatever.
or no, yeah, or a notebook. But the cool thing is that some of these things, they're SPARQL queries. They have variables. They can be parameterized, and so one nice thing might actually be able to be is to have kind of these more complex views either on individual entities or on entire classes of entities that show kind of show a story about that thing.
So Jamie, that to me it seems like this is like a next level, um, to really demonstrate this from a data science perspective. It seems like a really compelling thing would be to use something like Jupyter as as essentially a client to this, right? So that imagine that you've got some very rigorous report that you're putting together,
Mm-hmm.
and you're getting you're doing whatever like a sufficient specification of stuff in your notebook, and it's hitting Whyis, it's hitting the visualization capability Whyis, and pulling in the visualizations as sort of sufficiently described in the notebook, right? So that you're slurping in and doing the right thing with what you're creating. You understand what I'm saying? So rather than going to Whyis to interact with these, perhaps you design them in Whyis as you're doing here, but you're creating your report and you're instantiating all of that in your Jupyter notebook,
Right. Yeah.
or other notebook thing.
Yeah.
I assume that can Jupyter do like LaTeX?
It does Markdown.
It does Markdown. Okay.
Yeah.
But you see my point, that where
Yeah.
you're going from you're using this as to support, so you're not limited to just like being able to export the figure you're looking at. Why not slurp in that nano publication or whatever transformation of that you need into your notebook, to ultimately produce it, or overleaf. I'm assuming you're not going to pull it straight, and I don't know anything to pull straight into overleaf, but you get the point. Using that as your client, to this.
Right. And so basically, so yeah, I think that if there are tools, I don't know if Jupyter Notebook is quite the right one because it's very focused on kind of, there's an analysis that occurs in Jupyter Notebook that's kind of central to what it's doing.
Well,
But
okay.
some sort of thing where you're like composing, yeah, anything where you're really like composing a bunch of these pieces together into a report or a story or an article.
Right. I don't know what alternatives are out there beside. There probably are some, but I don't know besides, our notebooks in our studio, where
Right.
I know in our studio using our Markdown, you can generate really nicely formatted, um, LaTeX
Yeah.
formatted things. Um, but even it is not as flexible. It's very difficult to get very, very good LaTeX out of it, right?
Right.
Whereas Overleaf, of course, is going to do whatever, but that's not really a notebook format. That's a LaTeX authoring thing.
Right.
But
So in one sense, I think like having the ability to like ask for a PNG of this visualization would be valuable for that sort of stuff.
Mhm.
And even there, like if you wanted to have like a formatted figure, like a LaTeX figure segment, that would be pretty trivial to do as a Whyis view.
So so this, what we're looking at right here, this visualization, and so we've got the chart information, which I assume could double as like it could double as a caption, or it could double as it could slot it in. Does that have a resolvable URL to it? So could I make a request for this figure on the right? Could I make a request for the content on the left? Could I do that separately? Or does it come back as a big slurp, like a big JSON slurp that I would have to process?
So right now you get a view. If you do view as described, you can actually get all the JSON you need to produce that figure. And so if you run this SPARQL query, not this SPARQL, this SPARQL query against this endpoint, and then stuff the results of that into this Vega spec, you'll get that chart.
Mm-hmm.
So if you know how to use, so for instance, we could have like a library in Python for Jupyter Notebook that says, go look at this thing in Whyis, and it's a chart, and render it. But the kind of, in a more valuable sense, or possibly, potentially more valuable on the other side would be to actually have the, we can make a view of this that I guess could provide what, maybe what our notebooks would want in their spot to show a figure, in what LaTeX would want to show a figure there. And those are all text, right? So it's not actually that hard to.
Right. It's a kind of equivalent to content negotiation. The old Fedora URI, I'm sorry, digital library used to do something like this, where if I have a URI to my object, and I can request a particular manifestation of that object, right? So you had a URI that's describing this figure here.
Mm-hmm.
I guess we're looking at it. We're looking at the resolvable URL of it, right?
Right. Yeah.
But I should be able to do I should be able to make a request and bring back the SPARQL query of that, or I should be able to make a request and bring back a rendering of that, a PNG of that. Just knowing that and how to make my request.
Right. And so the SPARQL query you can get from the describe, and then the PNG we could theoretically. I mean, so there's the thumbnail.
Yep.
So there is that URI that you can kind of go to, and that might actually be the most appropriate way to send something back. And it could be that, like, if you ask for image, if you have if you ask for a image for a given entity, that it returns a depiction, right? That could be the right way to do content negotiation.
Yeah. So, well, you made a good point before. Walk before you run. You could have a Python hack that would know the right things to do, given just this. Given this URI, and it's I know how to deal with that, and it would do the right things and kind of construct it on the sort of the wherever the Jupyter was running, right?
Yeah. Well, the other thing is that Jupyter could actually show this, right? I mean, maybe not with all the extra. We might want to have a simplified view for something like Jupyter, but Jupyter is designed to embed HTML in it. So if we said, like had a include directive or an embed.
Yeah. Well, more or less, to do that experiment legally, you'd probably want to have an embedded Jupyter in your Whyis installation, because otherwise you can't do embeds from the other servers. What do they call it?
The course, right?
Yeah, so you'd have to do something different. But anyways, so we're getting to 6 o'clock here. Was there some other something else, Jamie, that you wanted to really show?
No, that was pretty much it. managed to fill in the time nicely. Thank you.
Well, no, this is really amazing. I mean, it's very, very cool, and it's come so long. And I think your decision to use Nanomine as your example for the talk was excellent, because it's so diverse. There's so much diverse information in it that it really shows your visualizations really well. And I'm sorry that I kind of dominated questions. Everybody was free to interrupt. They didn't. They said, I'm the what do you call it? The surrogate, the proxy. But
Yeah.
let's all thank Jamie. Come on, off of mute. All right.
Shy.
Thank you.
Okay. Hey, thanks a
Thank
lot.
you very much. And sorry for there was a mix up about the time and stuff like that. I got to drill it into people's heads.
Yeah, I think I'm still used to the live time.
Muscle memory.
Go with that.
Thank you very